right? Calculation will be the difference between these three means first quartile and third quartile. Difference between first quartile and third quartile is interquartile range. If you have learned statistics, you know that interquartile range. Then from this third quartile, 1.4 times of interquartile range is calculated to obtain inner fence. Then 3 times of interquartile range is used to identify outer fence. Similarly, from first quartile, 1.5 times of interquartile range, 3 times of interquartile range outer fence. Q1, Q3 difference make a වෙනස අන්තර්ජාතෘතක පරාසය. ඒකේ 1.5 ගුණයක් මෙතන ඉඳලා ගත්තොත් inner fence අභ්‍යන්තර වැට. 3 times ගත්තොත් outer fence බාහිර වැට. Right, that is the normal construction according to the data set manually. But you don't want to do that. You can identify in your data set for all these variables, there may be a small circle in your data. පුංචි මෙහෙම round තියෙන්න පුළුවන් circles. Those are milled outliers. ඒකට කියන්නේ milled outliers. Milled outliers. Milled outliers means they are innocent. ඒවා අහිංසක ඒවා ගැටලුවක් නැහැ. Small circles. Check whether in your data set there are star marks in your data. පොඩිම තරු තියනවාද කියලා බලන්න. If it is, these are all extreme outliers, dangerous outliers. Extreme. These are the problems to make our analysis wrong. මෙන්න මේවෙන් තමයි අපේ analysis එක වෙනත් දිශාවට, වැරදි දිශාවකට ගෙනියන්නේ. If you do not have these star marks in your data set, you can say and provide this graphical presentation box whisker diagram in your research data presentation and analysis. You can interpret no extreme outliers in your data set. Therefore, data set is normal. Extreme outliers නැහැ කියලා කියන්න මේ පුංචි පුංචි ඒවා තිබ්බට කමක් නැහැ. මේ circles ඒවා milled outliers. ඒවා අහිංසක data point විතරයි. මෙන්න මේව නැහැයි කියලා පෙන්නලා data set එක normal කියලා justify කරන්න පුළුවන්. Descriptive statistic ප්‍රශ්නයක් ආවොත්. If you do not have a problem with regard to the descriptive statistic, 3 methods: skewness, standard error of skewness, standard error of kurtosis. If you have problem, all these 3 methods, take box whisker diagram and provide that graphical presentation in your data presentation analysis. Now extreme outliers, how you can address that? It will be given a point, right? 5th data point, 10th data points. Like that, statistical or graphical presentation will provide that data point. You can identify that very easily. Then in the particular variable, you identify mode or median. මාතේ හෝ මධ්‍යස්ථය අරගෙන that outlier is adjusted to mode or median. මේ වගේ outlier එකක් තිබ්බොත් ඒකට මධ්‍යස්ථය හෝ මාතේ දාලා adjust කරනවා. Then data will become normal. Why we do that? When you are collecting data, there may be some extreme cases. Suppose that you are going to collect data from a supermarket. In the particular day, 1 or 2 customers may be coming. They are very extraordinary, but not the general public. Normally, customers we want to analyze. සාමාන්‍ය customers තමයි analyze කරලා decision එක ගන්න ඕනේ. එදාට මොකක් හරි හේතුවක් නිසා extreme outliers, extreme customers එන්න පුළුවන්. These are represented by outliers. Otherwise, no problem. Right, now I will show how to take this box plot. Right, this is the way. Right, now I take data sheet. Right, in this data sheet, you have created this variable. Last week we constructed these variables. Right, now I want to construct graphical presentation box whisker diagram. අර descriptive statistic එකේ ප්‍රශ්නයක් වුණොත් විතරක් විතරක්. Otherwise no need. Right, how you can take graph, legacy dialogues, then come to box plot. Right, in the chart window also you can use, but use this one, box plot. Construct graphical presentation box whisker diagram for all variables now, which have been created after testing reliability from batch alpha. Box plot, but all the variables I want to take, select summaries of, click on define. Now select to box represent all your variables, 5 variables. These 5 variables. Retention dependent. Use this arrow, only that. Right, now click OK. Then you can find your graphical presentation box plot. Right, now in the box plot, you can see these are the box plot. When you take these 18 data point and 6 data point, they are mild outliers. Mild. මේවා අහිංසක outliers item. Therefore, they are not dangerous items. If you could see any star mark, that is the problem. Then you can address this star mark. Okay. Right, these are not problem. Your data set is normal. Right, I will adjust hypothetically some data to show extreme outliers. Now take this data. Okay, in this data retention, right, I am going to change this one. Right, I change this 2.6 into 4.8 or something. I don't know still whether it is outlier, but you can check. Right, now I test again box whisker diagram. Box plot. Define until I reset whatever I have selected, they are there. Click OK. Now you can see here, fourth item is star mark. If you have any star mark, that is dangerous. This is extreme outliers. Extreme. Maybe extraordinary customer. Or maybe extraordinary employee. Maybe. But we have to drop them to generalize our results. Finally, in your result, in your research, you want to generalize your findings to the particular area, organizations, industry, country, worldwide, to whatever. Now, then this is a problem. Then how you can do retention variable, there are outliers, right? Retention. This one. Then what I do, I calculate mode than median, mode or median, whatever you prefer, you can do. Right, this variable. Go to analyze, descriptive statistic frequency, select your variable that is having outlier, extreme outlier. Click on statistic button, select median or mode. No need both. Whatever you prefer, you can take. Continue, click OK. Then now you can see median 2, mode also 2. Right? Whatever you prefer, you can take, right, mode 2. Then what I do, that outlier is the observation 4. Then I go to observation 4 of the retention, fourth observation is this one. I adjust that into 2. Then when you check no outliers, extreme outliers, right? Again, I take this recent dialog box, defines, then I construct box plot, but it is not an outlier. It is not an outlier. Like that, you can address if you have any problem in your data set. Data set එකේ problem එකක් තියෙනවා නම් ඒකෙන් adjust කරගන්න. Right, mode median you can use. If you want to use mean, you have to delete that outlier first. පළවෙනි outlier එක delete කරන්න. Drop කරන්න. After that, you can calculate mean value. Then again that outlier you can adjust with the mean value. Mean එකට adjust කරනවා නම් outlier එක පළවෙනි drop කරන්න ඕනේ. ඒ නිසා mode median පාවිච්චි කරන්න. Right, in this data set, hypothetically I did that, therefore I undo that. I take that data as it is, 2.6. Right, this is the way you have to address your normality. Now, one objective I believe that you can address. That is to identify nature or level of the responses made by customers, so employees, managers, whatever. ස්වභාවය හඳුනා ගන්න පුළුවන්. Performance evaluation වල ස්වභාවය සහ retention වල ස්වභාවය. That's what we did. All these belong to descriptive statistics. විස්තරාත්මක සංඛ්‍යාන. Beyond that, all the techniques we learn, they are inferential statistics. Now, these techniques belong to inferential statistic. Inferential, otherwise you can say analytical statistics. The විශ්ලේෂණාත්මක සංඛ්‍යානයවත් අනුමිතික සංඛ්‍යානය තමයි මෙතන ඉස්සරහට යන්නේ. To address your other objectives. So nature එකක් හඳුනා ගන්න කියලා කිව්වොත් විස්තරාත්මක සංඛ්‍යානය. If you are going to test your hypothesis, you apply inferential statistics. For an example, you may be having objective to identify relationship between performance evaluation and employees retention. Relationship. Now I am going to study this objective to examine the relationship between performance evaluation and employees retention. Right, suppose that you have objective. Then maybe you have developed your hypothesis. Performance evaluation criteria has a significant effect on retention, HA1. පළවෙනි කල්පිතය විදිහට develop කරලා තියෙන්න පුළුවන්. HA1. Second hypothesis may be HA2. I said at the beginning, no need to define both null and alternative. Define alternative only. Fairness has a significant effect on retention. Rewarding has a significant effect on retention. Like that, correlation, you might have developed PEC and retention has a positive relationship. Otherwise, there is a positive relationship between PEC and retention. There is a positive relationship between fairness and retention. Like that, you can write. No problem. Right now, any objective to identify the relationship, association, then you have to apply your analytical technique, that is correlation analysis. Correlation analysis. Right. Remember, any researcher has developed to identify the relationship, the analytical techniques is correlation analysis. On objective එක ලියලා තියෙනවා නම් relationship එකක් study කරන්න correlation analysis එක වෙන්න ඕනේ. Right? Therefore correlation. In the correlation analysis, powerful technique is Pearson correlation. Pearson correlation. Therefore, you can use Pearson correlation. Right, now I want to give important point in inferential or analytical statistic, how to test your hypothesis. What is the guideline? One guideline is there in the world, you have to do accordingly. මෙන්න මේ guideline එකෙන් තමයි හැම එකක්ම test කරන්නේ inferential statistic වල. So remember, you want to test hypothesis. When you test your hypothesis, a statistical package is providing p-value. 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 This is called significance value. Package is providing sig. Sig means significance value. This is just the probability. Make a sambhavitav. Probability. How we take that value? When you take this p-value, if your p-value less than or equal 0.01, that result is highly significant. Highly significant. Right? That's why researchers say result is highly significant. ඉහළ වෙසෙසියාවක් තියලා තියෙනවා කියලා කියන්නේ ඉහළ වෙසෙසියාවක්. p value 1.01 හෝ ඊට අඩු. If this value less than or equal 0.05, more than 0.01, but less than 0.05, this is called significant. This is significant. Significant. Make it kind of වෙසෙසි වෙනවා. If this p-value less than or equal 0.10, this is called marginally significant. Marginally significant. Right. Then p-value more than 0.10. More than 0.10. Equal is not there. More than 0.10. Then the result we say insignificant. 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 Right. This means that this is the 99% confidence, 99 විශ්‍රාම්භ සීමාව, 95% confidence, 95, 90% confidence, 90 විශ්‍රාම්භ සීමාව. Otherwise, 1% significance, 5% significance, 10% significance. If you have that p-value provided by the computer output, statistical package, these three situations, null hypothesis is H0 rejected. H0 rejected. Right. When you read the literature, you can see result is significant, hypothesis is accepted. Why it is? Null rejected. Null rejected means alternative is accepted. Alternative accepted. In our research, we develop alternative hypothesis. That's why result is significant, hypothesis is accepted. Hypothesis is accepted means alternative hypothesis we have developed. අපි රිසර්ච් එකේ ලියන්නේ ඕල්ටර්නේටිව් හයිපෝතසිස් එක විතරයි. මෙතඩොලොජි එකේ. ඒ නිසා රිසල්ට් එක සිග්නිෆිකන්ට් කියපු ගමන් හයිපෝතසිස් ඇක්සෙප්ට්. ඒ කියන්නේ ඕල්ටර්නේටිව් එක තමයි ඩෙවලොප් කරලා තියෙන්නේ. Right. Now p value more than 10% result is insignificant. H naught is accepted means alternative is rejected. That's why we say hypothesis is rejected. Hypothesis is rejected means alternative rejected. Null accept. H naught accept. This is the guideline to test the hypothesis. Some researchers think that I am not going to test 10%. If it is, forget about these two marginally significant. Right? They have to take insignificant p-value more than 0.05. If you are not willing to test at 10%, that is 90% confidence, you can use more than 0.05 as insignificant. But in management and social studies, no problem, 90%. Some medical treatments, we try to take 95% or 99%. That is with regard to the lives. Right. This is the guideline. මෙන්න මේ guideline එක තමයි හැම test එකකටම පාවිච්චි කරන්නේ. Remember